right, so here it is. Here is the big assignment. Do you remember the model here that we created, the solid model? Well, our job is to go in there and create some engineering drawings for fabrication that include proper views as well as annotations, notes, center lines and center marks, and dimensions. Okay, and since we have a solid model, we don't need to draw anything. We can just use the model as the basis for our views. Okay, so here's what we're looking for. This is in your course pack on page 187. Well, let's take a look at what we're starting with over in AutoCAD. So I've got my model, and my model looks super duper. We want to make sure our front view looks like this, and if it doesn't, use the gizmo to flip it around in 3D space until it's got the right orientation. Right, and what should we have on our layout? Well, we should have nothing except the title block and border. So you can get rid of a viewport if you got a viewport there. And then we're on layout 1. So I'll go back to the model and I'm going to say, okay, I want to get a base view off of model space. And I want that object. Enter. Enter again. And then there it is, looking all pretty and floating through space, right? So, front view, top view, looks good. Adjust as needed. Project extra views if you need them. And then up here we want a little isometric view. All right, put things where we want them. Now the ISO again is too gigantic. We need to change its size. So we're going to talk about making a custom scale. How do we do that? We're going to go to Scale, List, Edit. Scale, List, Edit. Okay, when we start this command, Scale, List, Edit, what it's going to do is it's going to bring up a list of available scales in AutoCAD. Alright, so in your file, in your blank file, if we just looked at your sample AutoCAD file, your template, and we type in Scale, List, Edit, one to one, 1 to 2, 1 to 4, right? These are all the ones we've seen and used, and here's all the architectural scales we've seen and used. And the reality is, this is not always going to be what we need. Sometimes we need to add our own scale. So what I'd like to do is I'd like to create a view that's 3/4 size. So these are 1 to 1, and this one is 3/4 to 1, or 0.75 to 1. Okay, so we can do that with Scale, List, Edit. We're going to add a scale. And now the first thing we do is give it a name. So we're going to call it 3/4 to 1 for the name. Now the name is just a name. You can name it Bob or Fred or Spot, doesn't matter. The important thing is down here. What are the ratios we're working with? So it's 0.75, 3/4 of an inch on the paper will equal 1 full inch out in model space. Okay, and that's what we want. And then when you say OK, you'll see that that is now one of the scales that we get to work with. And in fact, it would show up for the viewports too. There it is, 3/4 to 1, right? And it'll work when you are inserting models, or alternatively, if you made a view, you can go in there and you can look down on your list and you can find your 3/4 to 1 scale. And you see how it just made the isometric a little smaller. See, that's what we're looking for. Okay, so the isometric needs to be smaller. It can also be visible lines only or shaded with visible, depending on how you're feeling. Make sure your colors, of course, are not too dark. If you used white for your layer, you're going to get a big black blob for an isometric if you shade it. So we're using yellow and green and cyan and peach and pink and colors like that to work with when we're working in 3D. Alright, Got my multiple views, got my isometric at a reduced scale. And now let's take a look. What's that other view we're trying to create? What on earth is this thing here? See, it's not isometric, is it? Do you remember what you call this thing? You probably did this in the B12 class. So what can we call this thing? What is it? Well, it's called an auxiliary view. And again, this is a B12 concept. If you need a little refresher, look in your B12 course pack, or you can look over in Canvas. I have some stuff set up. It just basically says, look, when you have a slope, there's some distortion that happens in these views. So I've got a triangle wedge here, a little prism, and it's 3 tall and 4 long. And if I look at the top view, the ramp is 4 long. But if I look at this side view, the ramp is 3 inches tall. Well, which is it, 3 or 4? Okay, so there's distortion, like on my little house plan here. This window looks bigger than that window, but this window is on that wall, and this window is on that wall. So when I look at this window straight on, from like here, this one up here is smaller, even though it's the same size. But then if I look directly at the angled wall, now that window looks bigger, and the side windows look smaller, even though they're the same size, right? So what do we need to do to correct that? Well, you need to project directly off of the slope. And my 3-inch tall, 4-inch long wedge actually has a diagonal of 5. So this is the right shape and the right size, and when we do this, we're creating an extra view called an auxiliary view. There's also some shape distortion that goes on sometimes. For example, this little wedge here has a hole drilled in the face at an angle. So here we see they drilled a hole through it, perpendicular to the slope. But look at the top view. See, the hole looks like an oval. It doesn't look like a circle anymore. And over here, it looks even more squished, right? Why? Well, it's distortion brought about by this slope going on. So how do we fix that? Well, same idea. We could project the hole perpendicular to the face, and then we have a circle, right, that is really round instead of squished. So we're going to try to create an auxiliary view because we can't put a dimension for the hole if we don't have an auxiliary view. I can't put a diameter on an ellipse like here or here. And I can't locate it accurately if I don't have it flat or normal to my point of view. And then, of course, that creates some other issues. Look at this hole. This hole is round. Well, on an angle, that's going to look distorted, right? But that's okay, because what we're trying to do is we're trying to size and locate that circle right there for the big hole going through the block. So again, the way we do this is we create an auxiliary view. Now, how do we do that? Well, if I click the front view, there is no auxiliary view. If I project, I can get isometric in any orientation, and I can get orthogonal, front, top, left, right, back, bottom, but auxiliary is not an option. So, $1,000,000 mystery. How are we going to do this? Actually, you've already done it. Do you remember how to use the section tool? Now, think about it. If I cut through an object with the section tool, it produces a view in section. What's going to happen? Yeah, let's try that again. Section. Oh, let's section this thing. All right, there we go. Now, what happens to our section when we move the cutting plane? Right, if we move our cutting plane line, doesn't that change the section? Yeah, it does. I'll take it and scooch it up a little bit, and we see how that changes the section. So now think about it. What if you took a cutting plane and you didn't cut through the object, but just pointed at the object? Do you see what I'm getting out here? Yeah, so here's the basic idea. This is a 45-degree angle, right? So we're going to set our polar to 45. We're going to pick our front view. We're going to set up a full section, but we're not going to cut through anything. We're just going to draw a cutting plane line out in space. And doing that's not that weird. Actually, when you draw a cutting plane out in space, it's called a viewing plane. So now we're looking at things instead of cutting through things. All right, so this cutting plane is creating this auxiliary view. Now be careful, if your cutting plane is too small, it will cut off part of your auxiliary view. Okay? And if your cutting plane is at the wrong angle, it won't be a true auxiliary view, right? See that little crescent moon in there? That tells me that this is not a circle, it's an ellipse, and I won't be able to put a diameter on it. So make sure you got polar turned on, and make sure you are precisely looking at that 45-degree slope with a 45-degree cutting plane. If you do this, this should be a perfect circle, and you should be able to whip out a diameter on that thing. Now, if it doesn't, if AutoCAD won't give you a diameter, then one of two problems. Cutting plane is wrong, or the angle of the face is wrong. Okay, so you might have to go in and adjust a little bit. Now, I really don't need a cutting plane floating in space if I'm not cutting through anything. So if you click it, you'll see it's on its own layer called MD Annotation. We can turn that layer off without turning off the view. Okay, so turn that off. That'll get rid of the cutting plane. It'll also get rid of that big tag on the bottom that was identifying the section here. What are you going to do for this assignment now once you've got this set up? Well, you can add center marks to circles. You can add center lines through tunnels. You are going to use this drawing here as your guide for your annotations. Dimensions, angle dimensions, hole size, location. These holes up here are kind of freaky, so if you look at how I typed out the note, it's a diameter 0.5 counterbore hole that goes 0.2 deep. The through hole is 0.25 diameter, and they are typical since there are 4. Right? So if your note looks like my note, we'll be in good shape. You'll need a little note underneath this isometric because it's not one-to-one like the rest of this stuff. It's got its own scale, so it'll need a little tag underneath to tell you how big that one is. Right? And then the last deal that we need to concern ourselves with is how do you dimension the location of that hole? How do we show where it is? How do we put the center mark on there too? So putting the diameter on there was easy. Putting the center mark is going to be a little bit trickier. All right, so what will happen is if you go to use the annotate tools and put the center mark on there, it's going to give you a center mark that's going to be straight up and down, straight left and right. It's going to be an orthogonal center mark. So don't use the center mark tool for that. What you want to use is you want to create your own center mark. See, you're going to want to draw 2 center lines that cross, because if our view is at 45, our center mark should be at 45 too. Okay, and then what we can do is we can extend our center mark out a little bit past the edges. Like that and that, and that and that. All Alright, and then when it's time to dimension, we've got something to dimension to. Dimensioning this thing is going to be a little tricky. So let's do it together. You want to use an aligned dimension. Okay? And now let's be real careful. We're going to dimension from the quadrant to the edge down here, but to get there, don't click here, snap to perpendicular. So I did a shift to right click, and there's perpendicular, and then check it out. My dimension is now lined up at 45 degrees with the location I started at. I'll do the same thing here. I'll start the quadrant, and instead of clicking down there, which will give you some goofy measurement, that's crooked, don't do that. Give a click here, shift and right click, snap to perpendicular, and then there we go. Alright, so if you modeled it correctly, you'll have a 1.5 inch diameter for your circle, and then it'll be 1 inch up from the edge and 1 inch over from the side, and now that auxiliary view is properly constructed and properly annotated. Alright, if you're having problems, if the hole's in the wrong place, well, you know, you can move stuff, right? You can go in there and select your solid, and you can hold down the control and select the inside of that thing. And if you have to, you can move those elements, or you can hit delete and delete the circle, delete the hole, and put in a new hole, right? Make the adjustments after you do your dimensions, and then we'll see if things are correct. All right, so we've talked about how to take our model and how to stick it on a piece of paper, how to make views, how to make some specialty views like auxiliary views and section views. We even talked about how to add dimensions to this auxiliary view and how to make your center mark for an auxiliary view. One last little thing we want to do is we want to add a note to this drawing. Alright, so what kind of note? Well, the note's going to be right there above the title block. The height is going to be your standard height. And what we want to do is we want to talk about calculating the volume of this part. Okay, so volume. How do we calculate that stuff? Well, back in school, you know, you learned about area and volume and, you know, the different formulas for those things. Well, of course, we're going to not try to break this into simple shapes and then do a whole bunch of longhand math to find the volume of the solid. You're going to type in volume as our command, select the object, and then it's going to tell you what the volume is. Okay, so you can take that value and you can copy it, and you can go over to AutoCAD on the paper. My apologies, you can go over to Paper Space, and right out of the Mass Properties box there, you can add the volume. Volume 9.07, and then you got to either say cubic inches or if you want to get real fancy, you can say inches 3 and then use a superscript. All right, if you're working with multi-line text, you can say take the 3 and stick it up in the air. Inches cubed. So whatever you get for an answer, make sure your volume is reported. It is part of the drawing, and it's how I make sure that you actually modeled everything the right size and correctly. Okay? And like I said, that information can go right above the title block when you're all done. So the ultimate goal is right here. Right? We want our drawing to look like this when it's all finished. We want views with dimensions, an isometric, a scale note, an auxiliary view. proper note on your counterbore holes, and either above the title block or off to the side of the title block, the volume reported in cubic inches. All right, so have at it, and may the force be with you.